we are going to interact on design thinking approach in beam deflection. You are all very clear, I believe, that you know beam deflection is a concept of boundary value problem. Already we have discussed, am I right? Already discussed boundary value problems that are occurring in engineering. Even heat flow is a boundary value problem. Similarly, beam deflection, finding the bending of the beam, all those things are boundary value problems. So in this case, so today we are going to discuss how this design thinking approach can be applied in beam deflection problems. For example, I have taken the example as overbridge. We have overbridges. We have seen in various areas in our city we have bridges, over bridges, and we use the bridge for maybe pedestrian people are walking over it, many big trucks are moving on it, and we have various vehicles over it. So, what is the important thing you should take care of? It has to have that strength, that stability, that structural engineering. It should be that level. It has to withhold, right? It has to hold that strength. It has to have that strength to carry out the load that comes over it. Right? So, in this, I am trying to understand design thinking. What is the first part of design thinking? So, empathizing. Empathy. What is the meaning of empathy? We should know the pain point of the customer. This pain point. What is the problem statement we are analyzing? So, pain point. So, here, this beams has to hold that is, it has to have the strength to the load applied over it. To hold the load over it. So, the civil engineer, as an engineer, an architect, whoever, he has to plan. He has to understand the empathy of the situation. Empathy of the situation, and you have to understand what should be done, how the pillars, the columns, that is the vertical columns, or how many columns should be given, what should be the gap between the columns. All those things he has to understand. So that is under the concept of empathy. Alright, what is the second one? Define. He has to define the problem. Alright, understanding the pain points. What are the necessary, that is the scenario. Based on the scenario of that problem, he has to define it. Alright, we have to define what is the actual thing he is going to do. What is the actual thing he has to do. So in this problem, the actual thing is he has to understand the deflection, how the deflection will happen, how will be the bending of the beam will be there. He has to understand that will be his problem. That is his definite. He has to define the problem in that way. Right? So what is the third one then? After defining the problem, what is the third one? So ideate. So third one is ideate. He has to go through various techniques. He has to go through various models, various tools, and he has to understand what will be the right tool that can be implemented in this case. What is the right tool that can suit here? He has to go through various techniques, various analysis has to be there, because it's a very important case, because plenty of life is going over and over every minute and second. Am I right? Every minute and second. So construction of bridge is not a very easy case. He has to know all the strength, the level of the mixing, what grade of cement has to be used. Everything should be calculated. So that how the deflection happens, it is connected with all those parameters. So he has to ideate. The right suitable concept, right suitable tool. Okay, methodology, like kind. What is the next one? Prototype. What is the meaning of prototype? So after understanding what is the right tool to be applied, he will do some way of working structures. Am I right? He will try working on it, and he will come out with some results. Am I right? He will do some methodologies, and he will come out with some conclusions, some results, and some outcomes. Okay, so that is what is called prototyping. So after understanding what can be the prototype for this case, for the beam deflection problem, after understanding what is the right prototyping, after finding the right prototyping for this case, we can go for testing, because validation is very important, because whether whether the prototype what I have done here is right or wrong. We have to test it. Assessments are very important. You study and after that you have an exam. It is for assessing you. It is for assessing you. Similarly, here also after fixing the prototype, okay. So it is very important is to go for testing. So you are seeing the outcome of the structure. Actually, after construction of the beam, people move over and over it, but you don't know what are the risk factors inside it and what are the things that is already taken care. What are the safety measures done? Am I right? Various things are there. So, as an engineer, he has to test the. Fundamentally, he will be testing the soil before starting the before starting this process. He will start from testing the soil. You will see that how that soil is actually, from there you will start. So it is construction of such kind of bridges are very important. It takes lot of tools involved into it. So testing is very important. After having a clear picture and understanding the validated results are fruitful for this particular case, you will go for execution. You will go for execution. So this is how the structure happens. That is the. So we can work out this kind of thing using design thinking. It's very useful in this case. Okay, thank you.